So guys, now we will going to discuss the data structure and APIs that we will going to implement in order to add thread pooling functionality to our thread library, right? So thread pool is nothing but it is a collection of threads, as I said. So we need to define a data structure which represent a thread pool, right? And data structure has to be nothing but it just represent a collection of threads. So it could be a linked list, it could be a binary search tree, it could be any data structure which can hold objects, as I said. So here you can see that I'm defining a data structure thread pool. The first member of this data structure is the head of the linked list, into which I will going to queue up the threads, right? Now I hope you have already gone through this GL threads. A GL thread is nothing but it is an implementation of W linked list and nothing else. If you are coming from the prequel course, then you must have already gone through GL thread. If not, then in the appendix section, I have added the lecture videos which explain the concept of GL threads. So GL thread is nothing but it is a W linked list library. I'm not stopping you if you have your own implementation of W linked list, then I would recommend that you can very well use your own implementation of any W linked list library if you have. So in this GL thread, the first member is nothing but it is the head of the W linked list, and this W linked list will going to hold the threads which are blocked or waiting in the thread pool. The second member is the mutex. We need a mutex to perform addition or removal of thread from this thread pool in a mutually exclusive way. From the previous diagram, you can see that in step number 6, a thread can come back and park itself to the thread pool, right? Now consider there are several threads which are running in the system, and at the same time those threads finishes up the work and they come back and park themselves to the thread pool. So in a way we are adding up multiple nodes in a W linked list in the context of different threads. And it is for this reason that removal of the thread from this thread pool or addition of the thread to this thread pool should be done in a mutually exclusive way that is protected by mutex, right? This mutex will protect this thread pool data structure from concurrent addition and removal of threads from this thread pool. Now that, as I said, that we will going to add threads data structure into this thread pool, it simply means that to the thread data structure that we already have, we need to add a member which represents a node of the linked list, right? So let's call this member as wait glue, and we will going to hook up this thread data structure into this thread pool that is in this W linked list using this wait glue. So here wait glue represents a node of a W linked list, whereas pool head represents the head of the W linked list, which at the end of the day is just another node of the W linked list, right? Now that we have discussed that what should be the definition of thread pool, and we need to add an additional member to our thread data structure, now we will going to implement these 4 APIs which implements the functionality of thread pooling, right? So the first 3 APIs are very simple and that we will going to implement in the next lecture video. The rest of the section of this course is all about discussing the implementation of the 4th API, which is thread pool dispatch thread. It is this API which implements all the 7 steps that we discussed in the previous lecture video, right? So the 4th API is important and all the logic of the thread pooling is implemented as a part of this 4th API. So we will come back to the 4th API again later, so let us straight away implement the first 3 API which are very simple and straightforward. So in the next lecture video, I will start with the implementation of thread pooling.